I'm Shanna. Welcome to Best Practices, focusing on equivalent fractions, 4th grade. Take a minute to read through the equivalent fraction funny image on the screen. This is a typical misconception that we have with kids, that the more pieces we have or the greater the denominator means it's a greater fraction. And we're going to look at a bunch of strategies today that are going to hopefully fix that misconception. Within the equivalent fraction unit, we're going to be modeling and exploring the addition of a fraction with a denominator of 10 as an equivalent fraction with a denominator of 100. You can see that we're going to be using base 10 grid models like you can see on the screen there. We're also going to be using visual models such as area models, number lines to identify and generate equivalent fractions, which includes using multiplication, but using that model so they understand why they're multiplying by a fraction equal to a whole. And we're including denominators of 2, 3, 4, 5, 6, 8, 10, 12, 16, and 100. So what does student learning look like in the classroom? You're definitely going to want to use those fraction circles and fraction tiles to model fractions, and then use other pieces to overlap and show that they're equivalent or cover the same amount of space. This is really going to help students understand what equivalent fractions are. It's still the same amount, it's just represented in a different way, and even moving to drawing those models and using multiplication to prove it. We're also going to get into number lines and using those number lines to first represent fractions like we did in the previous unit, and then moving once again into equivalent fractions and actually seeing that it's the same location or same point on the number line, which makes it equivalent. We're also once again going to move into exploring real-world problems that deal with making those models and making those connections, as well as using those base 10 grid models to represent fractions that are equivalent from tenths to hundredths, and then once again using that to add fractions that have a denominator of 10 with a fraction that has a denominator of 100. So models, base 10 models are going to be really essential for that. It could be base 10 blocks, and also base 10 grid models, as I said before. So what does student learning sound like in the classroom? You may hear each third is a group of how many sixths. We're wanting to see that they can break down 1/3 into 6 and see that 1/3 is equal to 2/6 using a model. What did you notice about your cake each time you made a cut? We want kids to see that the pieces are getting smaller as the denominator or number of pieces increases, and so that they're looking at that pattern. How could you find an equivalent fraction using a number line? Like I talked about in the previous slide, understanding that the equivalent fractions are at the same point or location on the number line, and how do I decompose one whole number line into those pieces to find that out? If we only multiply the numerator or only multiply the denominator, are we creating equivalent fractions? We want students to understand that once we get to that multiplication, we have to multiply the numerator and the denominator and use a model to prove why that happens. I need to make sure I'm multiplying a fraction equal to a whole. If not, I'm changing the value. And then why do the values need to have the same denominator before you can combine them? That's getting into representing those fractions with a denominator of 10 as fractions with a denominator of 100, and understanding they have to be the same size pieces before I can combine them. Here's some precise vocabulary that we want to hear students using as we hear them talking about equivalent fractions: area model, denominator, fraction, number line, numerator. So once again, as they're discussing the math with their other students in the classroom, we definitely want to hear this language being used. How will students demonstrate their knowledge? So here are some examples from STEMscopes that you might see. Here's from some different explorers. We have, once again, them using area models to represent equivalent fractions and prove it with multiplication. We have base 10 grid models whenever we're adding fractions with a denominator of 10 with a fraction with a denominator of 100. You might even see a fluency builder game like equivalent fraction match, where they're definitely matching models that have equivalent amounts. And then once again, we could extend it to have them prove with multiplication that they're equivalent. Here are some questions to ask to gauge student understanding. How do you know that 1/2 is equal to 2/4? What is another fraction that's equal to a half? We really want to hear students using models and strategies based on understanding of fractions to explain how they created an equivalent fraction equal to 1/2 and how they know 1/2 is equal to 2/4. We could even extend it and looking at those patterns that the denominator, if I half it, that's going to be the numerator. So one of those benchmark fractions, 1/2, is really essential for them to know other fractions equivalent to it. Also, how does 1/10 and 10/100ths compare? We definitely want to hear student understanding that they are equivalent and that maybe they even use a base 10 grid to prove that they're equivalent. So here's an engaging task or activity for home. It's called equivalent fraction match. Basically what you do is take index cards or post-its or whatever and record equivalent fraction pairs on them. You turn the cards over, and then it's kind of like a memory game where you turn over two. If it's a match and I can prove it either with an area model or multiplication, then I get to keep those cards and they're part of my points. If it's incorrect, I turn them back over and we continue playing. So here's an example of what we want to see in this unit. We definitely want to see fraction tiles and students using models to explore and understand equivalent fractions, as well as adding fractions with a denominator of 10 with fractions with a denominator of 100. We hope you got a lot out of this video, and we'll see you next time.